All right, welcome back to day one of particle motion notes. This is the backside of that first page, so if you could flip there, this is kind of where we're continuing. So this is just the previous example continued, but we're looking at a few more details about this particle. So again, we have the same equation. We're given in meters per second. It says in part F, when is the particle speeding up, slowing down, and we need to justify again. And they give us a hint, which is actually pretty helpful. It says, since speed is the absolute value of velocity, the particle is speeding up when the velocity and acceleration have the same sign, and slowing down when velocity and acceleration have opposite signs. So that's actually going to be part of our justification because that's how we know when certain things are happening. Okay, so if we have to know something about velocity and acceleration, we're going to have to use both of those equations at some point. But first, I want to talk about speed for a little bit. So speed is actually the absolute value of velocity. Because as you know, when you're driving down the road, your odometer doesn't go to the negative numbers. It starts at 0. You can be going 0 miles per hour, then goes up to whatever it goes up to. But your velocity can be positive, but your speed can never be negative. So I'm just going to note that. Velocity, my screen's doing something weird again. Velocity can be negative. Zero or positive. Remember that your velocity being negative, 0, or positive just determines what direction you're headed. Your speed, however, can only be positive or 0. Those are your two options. So that's where we're at with that. So we're dealing with speed, and I want to kind of show you how speed and velocity relate in terms of their graphs. So if we're using our velocity function, which if we pull it from the previous page or take the derivative of our particle, again, we get 6t squared minus 14t plus 4. That was our velocity function. Just took the derivative of the particle function. If I want to graph that, I'll just real quick tell you here. Your vertex is found by taking b over 2a here, plus or minus, depending on what we're doing here. So in this case, we've got 14 over 2 times 6. Our b value, remember, is this one, a, b, c. When you have it written in descending order. So vertex, sorry, this actually is opposite. Opposite of negative 14, which is positive 14 over 2 times a, which we get to be 14 over 12, which simplifies to 7/6 if you want to think about your vertex. Okay, you don't necessarily have to do that. I assume you have your calculator with you on this problem, so you could just graph it. But you know your vertex is at 7/6. We also know our zeros because we found our zeros in the previous problem. So when we set our velocity equal to 0, we got our zeros to be 1/3 and 2. So if you're trying to graph this, you know you're going to have a 0 at 1/3 and you're going to have a 0 at 2. That's where it's going to cross the x-axis, here and here. Your vertex is down here at 7/6. So you've got something like this for your velocity function. This is the graph of velocity, which we called v of t. If you look at this on Desmos, which I already have pulled up, you can see I have something similar here. So this is v of t, 6t squared minus 14t plus 14. If I click on these critical points, you can see that's 3.333 or 1/3. This is 2. And then this down here is our 7/6. So you can see that. I don't know if you can see that with my thing there, but that's equivalent to 7/6. Okay, our speed graph is the absolute value of velocity. So if you think about what's going to happen to this graph when you try to take the absolute value, anytime your output is negative, now all of these are going to be positive numbers. And so your negative 7.6 down here becomes positive 7.6 up here. So we're going to have to deal with that when we're looking at this. So if you can just imagine taking this and flipping it up here to be positive 7.6, that is what's going to happen with this graph. And when you do that, what I have done in blue there is then the speed graph. So where my velocity was negative, it's now positive. So if I come back over here to my notes, I'm just going to real quick sketch the speed graph so you kind of see the difference. Here's 1/3 again. Here's 2. Those are my points. If I plug in 0, I get 4. So might as well have that as an accurate one too. And then 7/6 be somewhere over here at some point, right in the middle here. And if you plug in 7.6, you get a value. If you go back to this, I don't know if it's going to give us this. We're at 4.16776. So I'm just going to do my best here to get this graphed correctly. So we're here, come back up, come back down, and that's what we got for this. So this is actually the graph of the speed function, which we said was the absolute value of velocity. So those are the differences between those two functions if you're trying to look at this. I suppose I should have had this at 4 as well to be more accurate. When I erase this, it's going to take the whole line away. That's okay. I can put it back. Okay, there we go. Now they're more accurate. So that's what we got going on there. I just wanted to show you visually what was going on. I know it doesn't ask you to specifically graph those, but I'm just trying to make you see kind of what the difference between those two. All right, back to the original problem. When is the particle speeding up, slowing down, and justify? We need to compare the velocity and the acceleration functions and see what's going on with their signs when we do that. So we're going to use a sign chart, but our sign chart's going to be a little bit different because we're comparing two different things. So in part F, we're going to use a double sign chart. And we're going to compare v of t, velocity, and a of t, acceleration. Sorry, don't need that. Okay. So again, v of t, I'm just going to write this so you have this here, was 6t squared minus 14t plus 4. And if we're trying to make a sign chart for this, we have to think about where our critical points are for v of t. Our critical points, which we get by setting this equal to 0, we already did in the previous example, were t equals 1/3 and t equals 2. We did that on the previous video. A of t, we never actually found any zeros. The equation, though, is 12t minus 14. If we want critical points, again, we have to set this one equal to 0. 12t equals 14 then. So t equals 14 over 12, or 7/6, which I don't think is a coincidence. That was our vertex over here. Think about that too. All right, so we've got critical points at 1/3, 2, and 7/6. And so we have to use all of those in our sign chart when we're trying to figure this out. You can do two separate sign charts, or you can just figure out v of t and a of t and the signs of each of those. And then we just want to know when is it speeding up, slowing down. So we're comparing the signs to both of these. So I'm going to start here at 1/3. Then we've got 7/6 because that comes before 2. And then 2. All right, so I'm plugging numbers in up here to my v of t. And down here, I'm plugging in a of t. So you have to pay attention to what function you're plugging numbers into. So if I plug in something that's less than 1/3 to v of t, I get a positive. Between 1/3 and 7/6, I've already done this, so you get a negative number. Between 7, 6, and 2, you get a negative number for velocity. And then 2 to infinity, we get a positive number. If we're dealing with a of t, so we're plugging it into this function over here, this 12t minus 14, if I plug in 0, I get negative 14, so that's negative. Summing between 1/3 and 7, 6, I also get a negative. Between 7, 6, and 2, I get a positive number, and from 2 to infinity, I also get a positive number. So we're looking for when are our signs the same. It doesn't matter if it's positive or negative, they just need to be the same. So they're the same here, and they're the same here. So when they're the same, that means it's speeding up. When they are not the same, or when they're opposite, that means it's slowing down. So we know when it's speeding up, so the opposite ones would be slowing down. And we have to justify our solutions. I've already typed this up again, so you can just see what's happening here. So I'll scroll down here. And these are conclusions based on our sign chart that we just made. So the particle is speeding up on 1/3 to 7, 6, and 2 to infinity, because v of t and a of t have the same sign there. And the particle is slowing down on 0 to 1/3 and 7, 6 to 2, because your velocity and your acceleration have opposite signs there. Okay, that is all I have for you. You can pause the video if you need to write that down here. Your worksheet is worksheet 1 on particle motion, which I have also uploaded to this week's folder. Please make sure that you complete that. When you look at that worksheet, it does tell you using your calculator on which parts and which ones you shouldn't be using your calculator on. So you can go ahead and take a look at that. Make sure you're following calculator versus non-calculator stuff when you are doing that problem. Okay, I will answer any questions that you have when we meet again in class, but hopefully this was enough to get you through that first worksheet. Good luck.